Assalamu alaikum, dear students. I am Saqib Abbasi, your further maths teacher. Here we have a question. The topic is related to the mathematical induction. We know that mathematical induction is related to a three step. Number one, n equal to 1, n equal to k, and n equal to k plus 1. First of all, we prove any question by using these three steps. Okay, there is the question y equal to x e power ax, where a is a constant. Prove by mathematical induction that positive integers dny dxn equal to a n x plus n a n minus 1 into a e power ax. For this purpose, this is the question, October, November 21. First of all, we write it, we let Pn, we write it, this first step is same as it is. Here we take its left hand side. For left hand side, we put here n equal to 1. So d1 dx1 x e power ax, we take its first derivative. How we take first derivative? First x is similar, then take derivative of e power ax. What's the derivative of e power ax? This derivative is e power ax, e power x into a plus e power ax, x e power ax. So this is our first derivative by using n equal to 1. Now take its right hand side. Right hand side. Uh, this one is right hand side. What is the right hand side? According to right hand side, we take n equal to 1, a power 1, x plus 1, a power 1 minus 1 into e power ax. For complete solution, ax plus 1 into e power ax. After doing all these things, e power ax plus e power ax. This is the similar. So our left hand side equal to right hand side. We have to prove our first conditions. Now we assume that n equal to k. We put n equal to k. This is our equation 1 in equation 1. So how to deal this one? D into k, y, d into x, k equal to a k x plus n a k minus 1 up to e power ax. Okay. Now we put n equal to k plus 1. What is our process? What is our thinking process? The thinking process is that we put n equal to k is left hand side from equation 1. What is the equation? First of all, I write it into this one. Yes, I think this is correct one. Now, look this one. You put here d power k plus 1 y into d x k plus 1 equal to a, okay, equal to how. Now how we deal this one, how to write it this one. Could we write it into this one, d over dx and dk into y dx k? Because by using indices rule, if the similar thing is added, it will be k plus 1 and also dx are multiply with each other, so it's k plus 1. So we can write it into this form. After doing all these things, we have to write d over dx. Now d over dx, and what is the value of dk? In above, we know that what is the dk? This is our equation of dk, this one. We write it into x. We put x equation here. A kx plus n a k minus 1. K minus 1 up to e power ax. Now here we use this is our u. This is our first function. This is our second function. Now we make here product rule. What is our product rule? What is our product rule? This will be product rule formula is we write it d over dx u dot v u derivative of v plus v derivative of u. This is your u and this is your v. Now I will write it clearly. This is your v. Okay. Now how you deal these equations? Now what is the derivative of its first function? If you write it u a k x plus n a k minus 1, because here u is similar from this way. Okay, I highlighted this one. This u and this u is similar. This u is you have to similar. Now, what is the derivative of e power ax? It's derivative of e power ax into a. Now plus, what is the v e power ax? It's your second function v. Now derivative of your u functions. So what is your derivative of here? Here we have only x equal to 1. This is our derivative because ak and ak minus these are the constant values. So we have to write it into this form ak, because all this value will be 0, x will be 1 and this value will be 0. Now ak x plus n a k minus 1 e power ax into a plus e power ax ak. After that, doing these things, we will take e power ax common from all the equations. Okay, we have a common e power ax. After taking common e power ax, this will be n into n a k minus 1. Okay, and also this a will be applied here. This is also ak, and this will be a, and here ak. We take its. After doing all these things, e power ax and it's multiplied by ak. The answer will be ak plus 1 into x plus this a multiplied by from here. It's n a k minus 1 plus k plus ak. Now we going forward. How to deal this one? E power k plus 1 into x. Okay, plus ak into k plus 1, because these minus minus cancel. We take ak from both this equation and e power ax we have remaining. This is our proof. This is our proof. Pk plus 1 is true. Now look at the above equation. Now how to prove this one? Look, this one. We take, if we put here dk plus 1 into y dxk plus 1. So ak k plus 1 x plus k plus 1 and a k plus 1 minus 1 into e power ax. Should this answer will be similar over this answer? So this is our true conditions. Therefore, we have proved the mathematical induction. First of all, we have to repeat this one. What is our target? What target is about? We have to prove this question by using mathematical induction. We put here n equal to 1. We get its left hand side equal to right hand side. After we put n equal to k from in your first equation, so we get this equation x, okay? After putting, we have n equal to k plus 1, we get our final answer is this one. This answer, because we solve its left-hand side, this one is our left-hand side. We have to solve our left-hand side, we get our right-hand side from n equal to k1, k plus 1. That's it. This is our complete question. In the end, you have to write our last statement because in examination point of view, it gets you 1 marks. Therefore, therefore, by mathematical induction, P into N dny dxn equal to a n x plus n a n minus 1 into e power ax is true for all positive integers. Positive integers. That's all. This is our complete question. In the next meeting, we will solve our new questions. Thank you.